Hi gang, welcome to Apples, a series where I talk about audio systems I've programmed and I try really hard to make it sound interesting. I'm Will, and today I'm going to be showing you how I set up audio regions for 3D spaces in Unity. The example I have for you today is a lake.
Yeah, I'm an audio programmer, not an artist, so we're going to pretend that this is a lake. Now before we dive into it, I'm going to go ahead and show you what the final result is, and then I'll walk you through how we got there. Now what you've just seen may look very boring and mundane on the surface, and the average player won't give it a second thought.
Welcome to my world.
But it is a bit more layered than it may initially seem. So what I've done here is I've created a single audio emitter for our lake that follows the player around, but cannot leave its watery confines. Now why would we need to do this? Well, we want our lake ambiences to have attenuated audio that realistically gets louder and quieter depending on our distance from it, but that maintains its maximum volume while we are in the lake. In real life, a lake is producing all sorts of sounds that are overlapping and combining in all sorts of interesting ways, and as a listener, you're hearing the synthesis of those sounds. In video games, sounds are emitted from a single discrete point, and it's up to us as audio programmers to try to use the logic of our engines and our middleware to simulate that in an efficient and convincing way.
So the method that I am using is to create a single intelligent audio emitter that follows our player around the lake, but cannot follow us outside of the lake. And the way we achieve this is actually pretty simple, so let me break down the components of how we did it.
First, obviously, I need a game object for the audio emitter. Second, I need to write a script that tells this game object to follow the player. And finally, I need a wall or mesh around the lake that our player can freely pass through, but that our emitter cannot. So let's get started. Now I already have a scene set up here that includes the lake object, a plane for me to stand on, and a player prefab with a simple first-person camera and movement script. So this sphere here is our audio emitter game object. For now, I have the mesh renderer active so we can actually see it moving, but I'll eventually disable that mesh so that there isn't a random floating sphere in our game world. So this is the portion of the script that controls how the emitter follows the player, updating its rotation and position on each frame. It uses a few references that I created at the top of the script, including to the player and float values that determine its speed. These are all public variables, so if you wanted to bring this into your own project, you could just fill in all those variables from the inspector window. If you choose to use this in your own project, be sure to add a rigid body component to the sound emitter and make sure use gravity is unchecked and your collision detection is set to continuous dynamic. And I would go ahead and mess around in the scene to see what speed your emitter should have in order to keep up with your player. For instance, when I first created this, I gave it a speed value of 3, and yeah, I don't think that's going to cut it. So 20 is what works best for my scenario. Your mileage may vary. Okay, on to step 3, building the wall. Now I use Pro Builder for this, and I highly recommend it. It's a pretty versatile tool and allows us to build 3D objects within Unity. As of 2020, Pro Builder is available from the package manager within Unity. Unity is known to change our layout every couple of years, so this might look a little different for those of you watching in the future.
Oh.
But if you're watching this in 2022 and you want to use it, go to Window, select Package Manager, go down to Pro Builder and install it. And now we'll just select Tools, Pro Builder Window, and now just build your wall. Because the lake I'm using is a circle, I could select the pipe from New Shape to construct my wall, but if your lake is any of these non-circle shapes, you're probably going to want to use the New Poly Shape tool and just trace around the perimeter of your lake, which is what I've done here. Make sure to select Flip Normals so that your walls are facing inwards towards your lake and not outwards away from the lake. And we're also going to want to check this static box at the top of our inspector. I've gone ahead and created some new layers from the inspector to ensure that the sound emitter and sound field collide, but neither collide with the player, and you can see those here. I think they're pretty self-explanatory. In the layer collision matrix, make sure that your emitter/player collision is turned off, and your player/sound field collision is turned off. Now if I go back into our scene, we see our player is able to go through the sound field wall, but our emitter cannot. Perfect. Turn off the mesh renderer for our sound field and the emitter, and I could stop here. But I want to clean it up a bit.
You may have noticed while walking around the lake that the sound emitter rapidly circles around the player, and it can kind of cause this sort of warbling effect, which we definitely don't want. So, welcome to step 4, making it not do that.
So in order to prevent that, I've made the sound emitter become a child object of the player only when we're in the lake, so that its position is fixed to the players. So the first thing to do will be to set up a trigger that detects when our player enters and exits the sound field. To achieve that, I've just duplicated the sound field object and called it sound field trigger, unchecked the flip normals boxes, and in the mesh collider component, checked convex and is trigger. And I can also immediately disable the mesh renderer. And now for some more scripting. In the script that controls player movement, I've now created two new functions, one for entering the trigger and one for exiting the trigger. Entering the trigger does three things. It makes the emitter a child of the player, it attaches the emitter to the player's position, and it freezes the X, Y, and Z positions of the rigid body to prevent it from obeying the physics engine, because if I didn't do that, the exit trigger just undoes these things by moving the emitter back to the top of the hierarchy and unfreezing the rigid body constraints, and it also does one more thing. As the script stands right now, exiting the trigger actually carries the emitter outside of the lake with the player. Another problem to fix.
Welcome to my world.
So in my emitter script, I've written a function that tracks the emitter's position over the last few frames, so when the player exits the lake, the onTrigger exit function now resets the emitter to a position a few frames before exiting the lake, to ensure that it remains within its audio region. But that pretty much does it for this. Let's see the final product.
And that's going to pretty much do it for today's video. Of course, this method is applicable to more than just lakes. You could use it for cave ambiences or a pool of lava inside a volcano. I just thought using a lake would be the easiest way to illustrate this concept. But anyway, I hope you all enjoyed this episode in the Apples to Apples series. If you're interested in incorporating this technique into your own projects, you can head on down to the link in the description down below. It'll take you to my website where you can download the scripts that I made for this completely free. It's a way to thank you all for watching. And while you're there, if you have any sound design or audio programming related questions or needs, please feel free to reach out to me through the contact tab on my website. I would love to chat with you. Thank you again for watching. I've been Will. This has been Groovin Apple. Stay groovy, everybody.